All right, guys. This is the last time I see you before your test. Test is on Thursday. We've got today to review, so I've got quite a few review problems up on the bell for the bell work today. And then I'll take questions out of the review packet. If you guys don't have any questions, I've got a couple highlighted. Number 1, Stephanie's sitting on a sidewalk. 30 feet away, Seth is beginning to ride their skateboard. They ride towards Stephanie and past her at a constant speed of 7 feet per hour. That's really ridiculously slow. 7 feet per hour? Like, I'm pretty sure I can walk 7 feet in about 5 seconds, but I'm not going to argue with it. Seth's distance from Stephanie in feet after t seconds can be modeled by, here's the first thing that I definitely need to pay attention to in this problem, by this equation. What does the variable d mean in that equation? Yes. Sorry, they beat you to it. What does the variable t mean in that equation? Time. Okay, if we're going to solve for something, we got to substitute into one of those two places. So what piece of information have they given us to work with? Have we been given a time or have we been given a distance? Yeah, we have t seconds here, but we don't know how many t is. We do have a number that we can substitute in for distance. So we're going to put 15 in the place of that variable d. And a lot of times at this point, what I'll see happen on the test is students will substitute that in. They'll get rid of those pesky bars on the outside, and they'll come up with one answer. What's the problem? It's not how you solve it, because what do those pesky little bars mean? Absolute value, which means distance from 0, yes. She or he will be that distance away at 2 different times. Once when they're on the left of Stephanie, and the other time when they're on the right of Stephanie. So we have to find a way of talking about this mathematically. How am I going to explain the difference between on the left and on the right so that I can figure this out? Yes. We're going to describe this in terms of negatives and positives. So what we had talked about before, if Stephanie is right here at 0, on the left would be negative 15, on the right would be positive 15. Once I have those two equations set up, then I can get rid of the absolute value bars because I've dealt with the 2 possible locations that are that distance away. Does that make sense? Question for you. If we were working in real life and we're talking about a distance of 15 feet away, like 15 feet away from where I'm standing right now, could I get away with only 2 directions? No. In real life, we'd have to go like all the way around me, right? But here we're just talking about like going down a hallway. So we're just looking about 2 places. So 15 is equal to 30 minus 7t, or negative 15 is equal to 30 minus 7t. If you did 30 minus 7t equals 15 and negative 15, that's fine. As long as the 7t is the thing with a minus sign in front of it, and the 30 is a positive, and the 15 or negative 15 is all alone on the other side. And then we need to solve each of these for t. No matter which equation I start with, what would my first step be? Subtract 30. Absolutely correct. We're going to subtract 30 from both sides. So here that would give me negative 15 equals negative 7t. And then we do what? Divide by? By negative 7. We're going to divide by negative 7. Do I get a whole number when I do that? No. So we're going to have to do some rounding. When you need to round, unless the directions say differently, you'll go 2 spaces after the decimal point. You can absolutely leave it as a fraction. I'm totally okay with that. So if you left this as 15 over 7, then you should be fine. The only reason why I would go to decimal form on this, even though it's not pretty, is when we're talking like real world situations, you would never say, I'll be there in 15 divided by 7 seconds. We would normally just give like an approximation. But by that same token, I also wouldn't say like 2.14 seconds, right? Probably not in a real life situation. Leave it as 15 over 7. Or I believe that comes out to 2.14. Can somebody correct me if I'm wrong on that? If I divided my calculator. I would have to round it. Okay. And what units should go on that?
Seconds.
Seconds. T is our variable. Seconds is the units. So what do we mean by these numbers? Seconds. All right, so there's one of our times. Then I've got to do the same operations for the other one. So I'm once again going to subtract 30 from both sides. That's not going to give me a positive 15 over there. Remember, we can't just change the signs on our answers. I would get negative 45 equals negative 7t. And then again, I'm going to divide both sides by negative 7. Let me get that out of the way. There we go. What do I get this time if I put it into my calculator? Because you can leave it as 45 over 7. .42 or 0.43, depending on how you round. If you round it to a decimal and your very last number is different than mine, we're still good. That's why I want you to give me at least 2 decimals, though, so that I can make sure that we're the same for at least the first 2 numbers, and that last number should be very, very close to mine. And then that would be seconds again. So there's our 2 times. Yeah, if you write 6.42, I would accept that as fully correct. All right, second problem. Second problem is review from last unit. This is a Unit 3 problem. My hint to you on this one had to do with that notation, because whenever I see something inside the parentheses like that, I know that means I'm going to substitute it in for x, but I need to know what I'm substituting it into. So this right here, put in for x. Do I put it into this equation right here?
No.
Why not?
Because of the inverse of...
Yeah, that little -1, that is the inverse. I can't take the 16 and put it into this equation because this isn't the inverse equation. I have to substitute into something that has the same name. So what does this mean? Well, it means inverse. If I'm going to substitute into the inverse, then I have to go and find it first. What word did I tell you guys needs to pop into your head whenever we see inverse? Switch. What are we switching? X and Y. I see X right here, but I don't see Y. G of X means the exact same thing as Y. So I can just kind of mentally replace that with a Y, and now I can do my switching. So I'm going to have, instead of Y equals, we're going to have X equals 4Y. Good morning, Isaiah. Thank you, sir. Minus 5. Okay, so we switched. Now what? I did switch the X and the Y. Now we're going to add 5 to both sides, because what is our goal in this next step? Why are we going to add 5? We need to solve for y. We need to get the y all alone. So we have to undo all of the operations that are over there with y. So we're going to add 5 to both sides. So I get x plus 5 equals 4y. Is my y alone yet?
No.
No, but it's close. What do I still have to undo? The multiplication has to be undone. What operation will undo multiplication for us? Division. So I divide this side by 4, and the rules of algebra say if I do it to one side, have to do it do I do it to just one thing on the other side?
No.
You do it to both. You do it to anything and everything on the other side. So we've got 2 pieces on the other side, so I'm going to do it to both of them. So I have y equals x over 4, or 1/4 x, plus 5 over 4. You could write that in decimal form also, because that's 1.25. The very last thing that we do when we're finding an inverse is we have to name it so that anybody else looking at this would know what it was the inverse of. How do I name this? Yes, G inverse of x is equal to 1/4 x plus 5 over 4. Now I have something that I can substitute into. I'm going to take that 16 and it's going to go in right here in the place of x. You can't put it into the first one, but you can put it into the inverse. Thank you, sir. All right, so I'm going to do that right now so that we can finish this guy out. G inverse of 16 is equal to 1/4 times 16 plus 5 over 4. 1/4 of 16. If I take 16 and I cut it into 4 equal-sized parts, it's the same thing as 16 divided by 4. What do I get? 4. Yes. So I have 4 plus 5 over 4 is the same as 1.25. So what do I get when I combine this all together? 5.25.
Wait.
Mm-hmm.
On the test, we're going to multiply fractions.
What do you mean by multiply fractions? Like multiply fractions to another number? Well, yes. However, remember, fractions mean what operation? Division. So you take the number, multiply it to the numerator, it's just a 1 up there, and divide by the bottom. You also have a fraction key on the yellow calculators that I have, so you could put it in as a fraction and then times 16. You could do that as well. I'm happy to show you how to do that. Yes, ma'am. Could you leave your final answer for the inverse as a fraction? Yes, you could. That would be 25 over 4, I believe. 5 and 1/4? Yes. I would add, yeah. 5 and 1/4 would be fine. Let me write those off to the side. Or 25, no, that'd be not 25, 21 over 4. That's what happens when I do stuff in my head without grabbing my calculator first. There we go. 21 over 4 or 5 and 1/4. Those would also be equivalent correct answers. All right, last one on the bell work, and then we'll move on to the review. It says solve for x. X has these weird things around it. What are the things that it has around it? Absolute value. Inside the absolute value is the location on the number line.
So what's the answer would be 2.4.
Yes. So if what we're looking for is on the inside, we're looking for where it could be on the number line. What it's equal to is the distance from 0. Which of those things do I know, and which of those things am I looking for? I'm looking for the location on the number line, because that's the x, that's the variable. That's the thing I don't know. What do I know? That it's 2.4 units from 0. If I told you that I was 2.4 miles away, I could either be where or where? Negative 2.4 or positive 2.4. Because I didn't tell you whether I was coming from the left or coming from the right. I just told you how far. So when I'm looking for what's inside the absolute value, I'm looking for the location. And we always have to give all possible locations, which with absolute value is 2 possible locations. So positive 2.4 or negative 2.4. You guys okay with the bell work? That hits a good chunk of the front page of the review. First problem on the bell work is very similar to problem number 1 on the review.
Is there a review on Canvas?
There is a review on Canvas, but it's different than the one on paper. The one on Canvas is worth extra credit.
Okay.
So we get extra credit now?
You get extra credit. If you do the review on Canvas, which I'll be perfectly honest, I would not want to walk into this test on Thursday without having seen you guys on Wednesday and not reviewed anything right beforehand. That's why I have the Canvas review for you guys. I'm offering extra credit because I really, 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 really want you to do it.
You gotta do it before?
Before the test? Yes, please. It doesn't do any good to do it after the test. The test is on Thursday. Test over this unit. We are done with this unit now.
Come on, bro.
This was a very short unit, guys. All right. Go ahead and pull out your reviews. Does anybody need another copy?
I didn't get one.
I had passed these out last Friday. So if you were here last Friday, you should have one of these. Does anybody else need another copy of the review?
Thank you.
You're welcome. I want to open it up first and ask if you guys have any specific questions. Are there any problems that you're like, this one right here? I need help with this one. I don't know what I'm doing. Yes, sir. Number 2, absolutely. So number 2, parts A and B are very, very similar. So what I want to do is I want to go over one of these with you guys, and I want to leave the other one for you to do on your own, okay? I will put up all of my answers today about 5th period. They'll be up in Canvas, okay? I'm going to do part B with you guys.
Wait for number 4 up.
Did you want to do number 4?
No, I wanted to make sure because like, okay, for our number 4, it was like,
I was gonna say, I wanna do everything.
right?
Yes,
Okay.
except for the very last one, because why?
Wait, what do you mean?
We'll look at it together in a minute, and I'll point out the thing that I'm looking at. All right, so I'm doing part B. I want to know the transformations. When I say transformations, I'm looking for words. Tell me which way it moved. Hold on. How did it move is what I'm asking here. If I look at the x's first, what kind of directions are we talking about?
We on B?
Yes, I'm on part B.
Okay.
If we're talking about the x's, what are the possible ways that we could be moving? Left or right? The first table, the one on the left, this is always my original table. The one on the right is my transformed table. So if I start at 1 and I end up at -3, did I go to the left or to the right? Left. How far to the left did we go? 4 to the left.
Are they gonna say something?
Your guess is as good as mine. Left 4. Then I'm going to look at the y column. What are the possible ways that I'd be looking for moving here? Up or down. When I give you tables to look at, I'm not going to ask about stretches and compressions. It's too hard to look for on tables. There are ways. We don't have enough time to get into it in Algebra 2. So if I start at 6 and I end up at 4, did I go up or did I go down? How far down? Down 2. So minus 2, down 2.
Yes, 4.
So left 4, down 2.
This is just like describing a transformation, right?
Yep. So that's what goes on the first line. Anytime you see transformation, especially if there's a big long line after it, I want words. Down 2. On that second line, this is where I want the equation. So this is my new function name. Today is the 12th. We know that this function looks just like another function that we've been introduced to. The parent function, but the parent of what? What do we have to work with on part B? I have g of x. That's for this table right here. We said that this one is left 4 and down 2 from what function? Where did we start from? Here's my function g of x. F of x. The original function was named f of x. So that's the very first thing I'm going to put on this line after the g of x, because I don't have an equation for that table. So I'm going to put a letter f right here. And then inside parentheses, I have an x. This is my original function name. We said it went left 4. Left and right is always inside parentheses with x. What would I see in the equation if it went to the left 4? Plus 4. Why?
Because H is opposite.
H is always the opposite, yes. So we're going to see plus 4. Okay, so it looks just like f of x, but it is left 4. Did it move at all other than left 4? Down 2. So what would I have after the parentheses? Minus 2. I don't expect you guys to have all the words. I expect what's on the line, the f, the parentheses, the x plus 4, and the minus 2 on the end. That's what I'm looking for. I'm putting all those extra words up there because I want you guys to know what those parts mean so that you can recreate this.
Oh.
So for
Okay.
this didn't move. I just put it in.
Don't put anything for A. If it didn't go anywhere, your A value would have to be a 1, technically. Because remember, we always multiply by A. If I multiply things by 1, does it change? No. If I multiply things by 0, will it change? Yes, it would make everything a 0. So when I don't see A, when there's no change in A is 1. With left and right, H, or up and down, K, if you don't see those, or if there's no change there, those are zeros. Because the way I would describe not moving to the right or not moving to the left would be adding nothing. Or this direction, that would be adding or subtracting nothing. All right. There was a question about number 4. Number 4 is very similar to a bell work problem, but I want to look at part C. Look at part C with me. Am I looking for the location or the distance if you see the x where it is right there? Location. This is the location on the number line. This is what I want to find. What does this part out here mean? Distance from 0. This one's trickier than the two before it, than parts A and B. Why? Because it's a negative. But we said it means what? Distance from 0. What's the problem?
The distance can't be negative.
Distance can't be negative. This one is no solutions.
That went right over my head. Please don't. That's not what it says. Okay.
But it's an important concept, so I do keep bringing it up.
Yeah.
Distance can't be negative.
Wow, are there going to be these on the test?
We'll put it this way. The test is meant to see how you're doing with the big concepts. We go all the way from like the easiest parts of the big ideas to the more complicated parts, but my goal on the test is not to trick you. It's to see how much of the big ideas you've picked up. Yes, ma'am.
So you're gonna do like a lot of the word problems,
Like with the parabolas and stuff? Parabolas, not so much. This one, like those skateboard problems, those distance word problems, those are very likely to show up. All right, yes.
I could put this right here as 3.8 repeated. 5.83 repeated. I could
For
put
which
that
one?
on.
Oh, yes.
I could put it like that?
Mhm.
Okay, cool. And this was also repeated.
Ooh.
Did I mess up? I was overthinking everything.
So here you have -8. That should be, okay, you got 8. -52 divided by -12.
I could do this.
That's not going to be 70. Are there any others that you guys know you want to see right now? I know. That's why I'm going to put my whole answer key up, but I only have so many more minutes to actually talk.
We can do 5.
Number 5?
Yeah.
Okay, let's go look at number 5. Oh, yeah. And number 5 on the test, guys, like ones like this is easy points.
Oh, yeah.
Easy points.
Yeah, it really is.
All right, come look at this with me. Here's the equation that I want to use. This function down here that we see, I don't have an equation for it, but this is f of x. I want to graph this. So what would the transformations be? Give me words. Left 3, down 2. Left 3 and down 2. So now I'm going to take all those points that I see on the graph, and I'm going to make them do just that. I'm going to make them go left 3 and down 2. So this point right here, I'm going to grab it and bunny hop it, left 3 and down 2.
Hold on. We can choose which point we want to start at?
We're going to move all the points on that parent. So yeah, you can pick which one you want to start at.
So wait.
1, 2.
Could look different, right?
On this, everybody's graph should end up looking the same because they're all going to go left 3 and they're all going to go down 2. So left 3, down 2. That point's going to come right here.
But I'm saying with your graph still the same. You just
Your final graph should look the same because we're going to take all 4 of those points and we're going to shift them all the same ways. What do I need to do with this point right here? Left 3 down 2. So I'm going to bunny hop it. 1, 2, 3 to the left. 1, 2.
Left 3?
Right here.
Oh, I didn't do this one. Hold on. Wait.
Left 3 down 2. How many more points do I have to move?
2.
2 more points. I need to move this one. Left 3 and down 2. 1, 2, 3.
Okay, I got
1, 2. So right here.
This is all we're doing?
On this problem, yeah, that's why I'm saying this is easy points. Exactly.
So
1, 2, 3, 1, 2. He's going to go right here. All right. That's all there is. That's number 5. We're done.
So I forget
How to factor. Let's go back to number 3. We've had a question about number 3. All right. It says factor. General form, ax squared plus bx plus c. Which pieces am I looking at in part A?
A and C.
A and C. Is there a GCF here? No. No GCF, because we always look for a GCF. We only have 2 pieces. We only have A and C. There is no B value. This is a special situation. Yes, ma'am. Nope. Does anybody remember the special name we give it when it doesn't have a B value? Yes, difference of 2 perfect squares. Difference of 2 squares. How many factors do we get when we do a difference of 2 squares?
2.
2 factors. What is the difference between them? The signs. One gets a plus, the other gets a minus. And then I have to decide what goes inside. So what do I do to find the parts that go inside? Yes, square root of both pieces. What's the square root of 4x squared? 2x. That's going to go at the beginning of each factor. And then I'm going to do the square root of the c term. What's the square root of 9? 3. That's going to go at the back of each factor. If it's a difference of 2 perfect squares, you're done there. Part B. Do I have A, B, and C, or is somebody missing?
You have A, B, and
I have A, B, and C. Is there a GCF? Yes. What will go into everything? 3. So we're going to take a 3 out of each piece. That becomes part of my final answer.
You just leave it as 2x plus 3 and 2x minus 3?
The directions said to factor it. It didn't say to solve it. So
Okay,
yes.
right.
Yep. Good question, though. All right, so I got the 3 out of the way. So now I'm just looking inside the parentheses. So now I have a new A, a new B, and a new C. Can I use my shortcut on this?
Yeah.
Yes. What am I looking for to know whether or not I can use the shortcut?
A is 1.
A is 1. A is 1. Can use shortcut. So I've got this. I multiply A and C together up on top. So that's 1 times negative 15. I need 2 numbers that when I multiply them together, I get negative 15.
You didn't have to use it on that one. I don't think so.
For which one?
We was asking if you gotta use the box for number 1.
Nope. You can. You can do it with a box, but you don't have to. It's going to be unnecessarily large. What 2 numbers do you guys know of that'll multiply to negative 15 but add to a positive 2?
5 and negative 3.
5 and negative 3. Beautiful. So these are the numbers that I'm going to put inside my factors with x. So x plus 5, x minus 3, and if you put that as your final answer, you're going to get almost all the points, but it's not perfect. Why not?
Because you forgot the GCF.
Forgot to write down the GCF there. Remember what the F in GCF stands for? Factor. So if it says to factor it, we have to include that as part of our final answer. Yep. Answers are going up on Canvas for the entire thing right around 5th period today. I want to look at number 10 with you guys very briefly. Look at number 10 with me.
How many questions on the test?
Honestly, I don't remember.
It's a lot.
Shouldn't be that many. Usually it hovers somewhere between 11 and 15 questions, depending on how many parts the questions have. If they have lots of parts, it's fewer questions. If there's not a lot of parts, there's usually more questions. What are we looking at on number 10 that we haven't dealt with just about anywhere else on this review? Inequalities.
Yeah.
What do I have to do before I can deal with the fact that there's an inequality there? Isolate. We've got to get our absolute value alone. You always, always, always have to get your absolute value alone first. So I would add 4 to both sides. 3x minus 2 is less than or equal to 14. For part B, what would I need to do to isolate? We would have to subtract 3 from both sides over here to isolate. You always have to isolate your absolute value first. I want to talk about how to set each of these up. I'm not going to have time to solve them all the way out. That's why I'm putting my key up. But I do want to talk about the setup. Guys, one of the things I'm going to be looking for on the test is, did you make a reference sketch at this point? When we're dealing with those inequalities, if it says that I'm less than or equal to 14 units away from 0, where could I be?
Anywhere. Okay, anywhere between
Just 0.
14.
Anything. Okay, so here's 14. Is there another number that I need to be worried about on there? Negative 14. Anything in between those. Filled in dots or open dots?
Open. I mean, filled in.
Filled in because of that or equal to. When I make a reference sketch and it looks like this, that means I'm going to have a compound inequality. One inequality with those two numbers as the boundaries. Less thans on both of them. Compare and contrast that to this one over here. Part B says that it is greater than 21 units away from 0. What does my reference sketch look like here? Anything outside of 21 and negative 21. So moving away, trying to get away from 0. We are more than 21 units away from 0. Is it shaded in the middle? What does that mean? Union. Can I write just one inequality? No. On part A, I could write just one because it was shaded in one spot in between two numbers. This is shaded in 2 spots with a gap in the middle. So this is 12 minus x. What inequality do I use to mean pointing to the left? Less than. Less than negative 21. Union. Over here, is it pointing to the left? It's pointing to the right. How do I explain that with an inequality? Greater than. When I isolate my absolute value and I have a less than, that means we're going to be running together on that reference sketch, shaded in one spot. So I'm going to write one inequality with those positives and negatives on the outside of it, like holding it in. When I isolate my absolute value, if it's a greater than, I'm going to be running off in 2 different directions. That means 2 separate inequalities. One of them will have a less than because it's going to the left. The other one will have a greater than because it's going to the right. Yes, ma'am. Thank you. All right, there we go. Now I fixed it. Thank you, Melly, for pointing that out. Belzy, did you have a question for me? The little arrows. Oh, when I did my reference sketch, you can absolutely put the little arrows on there because it does continue on. I just did just a real quick sketch for like what's the big idea of what this looks like.
Can I get a glass?
Yes.